Hello. Hi guys, good morning. Welcome back to a new video. In this one's problem, find the grid of region average. Although it is marked as medium, but it is actually an easy problem, and you have to just implement what the problem is saying. That's it. So if you have not tried by yourself, just try coding it by yourself, and you should be able to code it. But still, if you want to see, let's start off. We are given a zero indexed m cross n grid image. So we will be having a m cross n grid known as image. M is the number of rows, n is the number of columns. That's a grid we have, which represents a grayscale image. Now what they mean by that is I comma j represents a pixel. That one cell I comma j, it represents a pixel, and the pixel value can be in the range of 0 to 255, which means this is the cell. So my cell is image of I and j, and its value can be from 0 to 255. That is the value what it can have. Now you are also given a non-negative integer called as threshold. So I have one more variable named as threshold. Now the next thing which problem says is we are given two pixels. Again, remember, one pixel is one cell. One cell, image of a comma b is one cell, image of c comma d is one cell. So two pixels or two cells are said to be adjacent if the condition, which means the difference between their x coordinate, absolute difference between their x coordinates plus absolute difference between their y coordinates, it is a 1. So if I just say as a visualization 0 comma 0, 0 comma 1, 1 comma 0, 1 comma 1. So you can see the absolute difference between these two cells will be a 1. Absolute difference between these two cells will be a 1. Absolute difference between these two cells will be a 1. Again, when I say absolute difference, I mean this specific value. And then the same way for these two. So you can simply say that these adjacent cells are the actual adjacent cells, right? And the same way goes for this also. Like this. This is the adjacent cells which we have in the problem. Now, the problem next comes and says us is that a region is a 3x3 subgrid where the absolute difference in the intensity between any two adjacent pixels is less than or equal to my threshold. So now the problem says is that in this specific grid image, I will take a 3x3 subgrid. I'll take a 3x3 subgrid. I can take this as a 3x3 subgrid. Now in this 3x3 subgrid, the absolute difference in the intensity between any two adjacent pixels is less than or equal to my threshold. So if this is my subgrid, now you know that these values are the intensity. So the absolute difference between the intensity, this should be less than equal to my threshold for the entire subgrid. As you can see, absolute difference in the intensity between any two adjacent cells, and again you have seen so far is that these two are adjacent, 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 these two are adjacent. Again, the same way I can simply say the same thing also as these two are adjacent, 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 these two are adjacent. That is how they have referred it. Now, so absolute difference in the intensity between any two adjacent cells, pixels, is less than or equal to my threshold, which is the given variable which we have. Now comes although the question is pretty big, but you should understand everything. Again, it's the reason I'm just taking that slow. All pixels in a region belong to that region. All pixels in a region belong to that region. Note that a pixel can belong to multiple regions. So as you saw, a region they have defined as a 3x3 subgrid. So a 3x3, this was one region, but to specify that it is a 3x3 subgrid can be a region. This specific 3x3 subgrid will be a region if all the adjacent cells intensity difference When I say difference, I always mean absolute difference. Absolute difference will be less than or equal to my threshold. So as you can see, any two values difference, any adjacent value difference in this specific value is less than my threshold of 3. That is the reason this specific 3 cross 3 subgrid is actually a region. And the same way for the next 3 cross 3 subgrid, this is also a region. So all the cells in this region belong to the region. So let's name it as a region 1. This is a region 2. Right, so this cell belong to region 1, region 1, region 1, region 1, region 1, region 1, and so on and so forth. Same, region 1, region 1, and region 1. And these cells belong to region 2, region 2, region 2, region 2, region 2, region 2, and so on and so forth. So you will see that this cell 6, 9, 12, they belong to both region 1 and region 2. They belong to both region 1 and region 2. And this cell R1 only belong to region 2. Region 2, region 2. So I can just specify this also, that a cell can belong to 2 regions also. A cell can belong to 2 regions also. So we have seen so far is that a cell can belong to two regions, multiple regions, and not only 2, it can have multiple regions. My task is now to calculate a zero index m cross n grid result. Now I have to calculate this specific value, which is a result, but it is not a value, it's a grid of size m cross n, where result of ij is the average intensity of the region to which image of ij belongs to. So this result of ij is the average intensity of the region it belongs to, image of ij belongs to, rounded down to its nearest integer. Okay, if image of ij belongs to multiple regions, result of ij is the average of the rounded down average intensities of these regions. Let's break this specific thing down. So we'll just see only the first thing, that you need to calculate a zero indexed m cross n grid result, where result of ij is the average intensity of the region to which image of ij belongs to. So if I ask you what is the average intensity of this specific region, region 1, so what is the average intensity? Average is nothing but summation of all intensities divided by count of intensities. Summation, again, you remember it is a 3 cross 3 grid. So count will always be my 9, which is 3 into 3. But the summation I will have to take in from here up till the super end. I'll take the summation. So let's say that this summation comes out to be a value R1S, which is the R1 region 1 summation divided by 9. This will give me the average value of this specific region, which average intensity of the region to which this cell belongs to. So this will give me the average value of this region. This is the average for the region 1. Now result of ij is nothing but the average of that cell itself. So average of region 1, average of region 1. So if I make the result array, itself of size 3, so as you can see, it is belong to region 1. So if a cell belongs to a region, its value will be nothing but the average intensity of that region. So you can see average intensity is R1S by 9. R1S by 9. Its average intensity will be R1S by 9. R1S by 9. As you can see, they belong to region 1. But Aryan, what if, again, if they belong to region 2, the intensity will be R2S by 9. R2S by 9. R2S means region 2 sum of all the 9 cells. Same, R2S by 9. But Aryan, the next statement says that, okay, and for sure they need the floor division, but they says that if the image of ij belongs to multiple regions, as you can see, the cell ij belongs to multiple regions, then result of ij is the average of the rounded down average intensity of those regions. So its result will be nothing but R1S plus R2S by 9. So it is nothing but rounding down the averages itself, or you can also say the same thing as the intensity, the average intensity which I have R1S by 9 plus R2S by 9 upon 2. This is the average intensity of region 1. This is the average intensity of region 2, and taking the average of those two averages by 2, because number of things which are above are 2. So for sure the average by 2. So I will have to do this. Okay, the same way you will see all the other also belongs to this same region. So all of them will have the same value. This is ultimately what you have to go and find as your answer. This is your final result array. This is your final result array. Now, if we look at the example itself, you can easily see that they have specifically mentioned that this is a region. This again, so what ultimately you are saying is that what I should do is I will go at every cell I comma j. Now from that cell I comma j, I will go and try for a subgrid of size 3 cross 3. Now to iterate on the subgrid of size 3 cross 3, I'll take the variable k l comma k, right, or let's say k comma l. I'll take k l, yeah, I'll take the variable as k comma l, which means k comma l will iterate in to the 3 cross 3 entire subgrid. Again, my ij will go on to all cells of the matrix. From each cell, I will again start a look for a 3 cross 3 subgrid to identify, and to start a search for a 3 cross 3 subgrid, I'll use the variables as k comma l, which will go on to all the cells in that 3 cross 3 subgrid. Now I will see for all the adjacent cells their difference. I will see for all the adjacent cells their difference. If that difference for all the after going on to all the 3 cross 3 grid in the entire 3 cross 3 grid, again how I will see it, I will just check. Let's erase this k comma l, but remember to iterate on the 3 cross 3 matrix, I am using variable k comma l. Let's put it here, k comma l. It will go, k comma l can be here. So basically it will go on to all the cells. For that specific starting cell as I comma j, I will make a 3 cross 3 matrix or grid or a subgrid, and then I'll go on to it. Now for this specific, when I have to check, I'll simply compare this cell with the previous cell, this cell with the previous cell. That was the adjacent cell name, right? And same way for this cell I'll compare the previous cell, for this cell I'll compare the previous cell, for this cell I'll compare the previous cell, for this cell I'll compare the previous vertical cell and previous horizontal cell. Okay, for this cell I'll compare the previous cell, for this cell I'll compare the previous cell vertical, previous cell horizontal, for this cell previous vertical, previous horizontal. And that's how, if all of them have a difference in their values, absolute difference in their values at a threshold less than equal to my threshold, then it is a good region. It is a good region, which means okay, it is actually a region. This subgrid of 3 cross 3 is actually a region. Now if this thing is a region, so go and find the sum. Go and find the sum of that region. Let's name it as RS. And you know for sure you have 9 elements. So the average value will be nothing but RS by 9. Now you know that all these cells, again let's name it as the first region. So you know that all these cells in the region, all these cells in this region belong to the region 1. So again, so you have to just make sure that ultimately by calculating the ultimately when calculating the answer, I should be knowing that how many regions it belongs to and what is the average value of that region. This is the average value of that region. For region 2, as you can see, average value will be R2S by 9. R2S by 9. It is R1S by 9 right now. So ultimately in the end, we will have to also calculate the average. You will also have to calculate the average value if it is belong to multiple regions. So rather than simply assigning, the first cell, again, you will go on. Now you have known the average for this region. This region average is nothing but R1 by 9, R1S by 9. So now you will go on to all the cells again for this region, and for all the cells, k comma l, all the cells, you will push back this specific region average, which is R1S by 9. Now Aryan, why I am pushing back, why I am not assigning it? Because it can happen that for the next region, again, a cell can be in multiple regions. So for the next cell, for the next 3 cross 3 subgrid, again let's say if it becomes a region, so the new region average for that cell can be a R2S also. So for every cell, I will just firstly figure out what, okay, for that, again I'll just have a quick repeat. For every cell I comma j, I will go and try for a 3 cross 3 subgrid taking a variable as k comma l. If that subgrid becomes a region, I will go and find the average of that region. Now average I have got. Now I will go back onto my 3 cross 3 subgrid, and for every cell I will go and push back this average value in its, let's say, region. I'll make a new vector. For every cell I'll make a new vector to push in this region average value, naming it as a region set. So for this 6, I will push in this R1s comma 9. Again, it will be a vector. For a cell, I will have a vector in which I will be pushing in values. Okay, for 7, I'll push back R1s by 9. And the same way, for 8, I'll push back this value. For 9 also, I'll push back. Why I'm pushing back? Why I'm not assigning it? Because next time, when the new region will come in, which is this specific region, I'll do the again same operation. I will go and firstly have a check that if the adjacent, absolute difference, all that stuff, it's less than equal to my threshold. If yes, then go find its sum. Go find the R2s by 9, which is the average of that region. Now go assign this average value to all the integers in that specific region. I'll assign all the integers this value R2s by 9. So you saw earlier my 6 was assigned a value R1s by 9, but it belonged to a new region which is R2, and it also got a new value assigned which is R2s by 9. So that is the reason I will be assigning, I could assign multiple values to a cell. Now when I have tried for all the possible regions, ultimately in the end for every cell I will have a vector of average region values. I will have to take the average of those average values. So I will just go back and take, okay, for this cell, whatsoever values are in its vector, which is v, let's say v1, v2, these are the values, let's say v1, v2, and so on and so forth. I would know that, okay, what all values are there. I'll take the summation of those values for this specific vector and dividing by the size of the vector for this specific cell. This will give me the result of this specific cell, and that's how I can simply solve it. Cool. It's only the play of implementation, because it's more of that do average, take again average, all that stuff. That's the reason. Now what is the complexity? Simply, as you can see, that you will go on to every cell, right? Okay, every cell going m cross n. Now for each cell I will have to go and find a 3 cross 3 subgrid. So okay, for each cell a 3 cross 3 subgrid I will go on to. Now for that subgrid, meanwhile, I will verify my condition that the absolute difference should be more than equal to my threshold. I'll also verify and get the sum, and also I'll get the average. Same in the same loop. And ultimately, when this entire thing is done for this specific cell, for one cell, I will go on and do a 3 cross 3. Now, when I have got all the region values, all the average region values for each cell, I will again have a final loop which will iterate on all the cells, again m cross n, and then for all the vector values, for sure I can have a maximum of 9 regions. For a cell I can have a maximum of 9 regions. So this will be nothing but a m cross n into 9 as a complexity, and you can see m cross n 500 into 500 into 10 will for sure work, and this is your answer itself. Cool. Let's see the code. It's pretty simple. That firstly I have my I and j. Again, this is the result set which I was talking about. That for each cell, what is the average region values I will be storing in that result set. So result set of I comma j is a vector which stores R1s by 9, R2s by 9, R3s by 9, and so on and so forth. It is a vector. Cool. Now coming on back to the main logic, I will simply go on iterate. I'll simply go on and iterate on my ing. Okay, for this specific grid, let's increase the grid size. For this specific grid, I am at the cell I comma j. For this cell I comma j, you have to go and try for a 3x3 subgrid. So for that, let's take the variable as k comma l, which will go on to all these cells, all these 9 cells. So I have my k comma l, which will go on to all these 9 cells, a 3x3 subgrid. But I'll also make sure that parallelly I am finding the sum of all those 9 cells. So I have taken a sum and also a variable known as is region, so as to make sure that if the absolute difference between the adjacent cells, if that difference threshold, if it is more than my threshold, sorry bro, if the difference is more than threshold, then it's not a region. Mark that as a false. But if it is less for all the cells, it's a region. So what I'll do is, as you know, this is going on to a 3x3 subgrid. I'll firstly add in my sum, no matter I use it or not later, but simply I'll add it now. Now I'll simply have a quick check that if as you have remembered that I am starting off my k comma l with this, so I cannot compare this with my previous cell or with my top cell, because comparing is for this 3x3 subgrid. So I'll compare this cell with the previous cell. So I should be knowing na ki my k comma l, if it is I or j, if my k is I or if my l is j, then please don't compare the previous cell value. Which means if I'm standing at this cell, I should not compare it with the previous cell, because the grid itself starts from k comma l. So if my k is more than I, which means my k is here or here, like this, or if my l is more than j, which means my l is here or here. It is just saying if my k is equal to I or my l is equal to j, then please don't compare with the previous cells. In these cases, I'll compare only with the top cell. I will not compare with the previous cell, because previous is not inside my grid, right? Okay, same for this my grid. So that's the reason it is a condition that okay, you should compare adjacency in the same matrix. Now I'll compare the horizontal thing that okay, if my k comma l and k minus 1 comma l. So if my k comma l and k minus 1 comma l, if the vertical adjacent matrix threshold is more than my threshold, if the absolute difference between them, vertical absolute difference, if it is more than my threshold, sorry bro, it is not a region. And the same way I'll check for horizontal. If my k comma l, and this is k comma l minus 1, if the horizontal threshold, horizontal absolute difference, if this becomes more than my threshold, then again it is not a region. But after you have tried off for the entire 3x3 grid, and still if it is a region, then do one thing. Now you know that this is a region. Now you know that this entire thing is a region. This box is a region. So find its average, find its region average. So R1 average will be nothing but R1 sum upon 9, and sum you have been finding out while you are checking also. So R1s you have, 9 you know for sure. So this is the average. Now this is okay for the region 1 average. So simply go and push back this region average for all the cells in that region. So I'll again go on and again iterate on my k comma l. I'll again go on iterate on my k comma l, but this time I will be pushing on my average in each cell, and that's the reason I will use a result set. As you have seen, I'll use a result set in which for each cell I'll be pushing back the average region sums, average region values. Cool. Now when this entire portion is done, which means I've gone on to all the cells, and for all the cells which were regions, I have pushed back their corresponding region averages. When this is done, it's now the time to find the result. Now Aryan, why have you assigned that to your image? Because the problem says that if the image I comma j, it does not belongs to any region, then please by default it should be equal to your image of I comma j. So by default I have assigned it to my image. If if that cell R result of I comma j, if it belongs to some region, then I will find by taking the average of those region averages and then giving that to a result. But if it is not a of basically if that image of I comma j, it does not belong to any region, then simply bro keep on like simply have the default value of image itself. So I'll simply say if my result set of I comma j, if it is not empty, which means it had belonged to at least one region, so I'll take the sum of that vector. This is the vector, I'll take the sum of this vector divided by the size of this vector, which will give me the average of all these average values. Cool. So I'll take the sum divided by the size of that result set of I comma j size. This will give me result of I comma j, average of the result average of the region averages for that specific cell I comma j. And again, by default it is image if it is not belonging to any region, and that's how I can simply return my answer result. I hope that you got it. That's the reason I specifically focused on the question more on every word, because that is the entire crux. The question understanding itself is actually the hardest part. Rest the question is easy. Goodbye.